Welcome to my channel NCERT Mitra. In this video, we are going to discuss one of the very important topic. Perhaps you know, perhaps you can see in my background, that is the seafloor spreading. In previous video, I already discussed two theories regarding this. You can say the formation of the mountain, formation of the continents and ocean. There's the continental drift theory and the plate tectonic theory. In this video, we are going to discuss the seafloor spreading, a key geological idea and one of the foundational concepts behind the plate tectonic theory. To begin, we are going to very back to the early 19th, and the German meteorologist, perhaps you know his name, that is the Alfred Wegener, who was proposing a radical new idea that is called the continental drift theory. Okay, perhaps you can see in my background, this person is known as Alfred Wegener. According to his idea, he proposed actually that the continents were not stationary masses, but rather than slowly moving slabs of rocks, and that interacted with one another and over the time. But in order to really make to sense of, you can see, this idea, we need evidence actually. Okay, so in his concept, he described about the three type of you can say the plates movement. Somehow today as it is known as the plate tectonic theory. But you can say, now the fortunate that after the Wegener date, evidence became available in variety of the forms, and that evidence also described the process that we now know as the seafloor spreading theory. Okay, in this video we are going to these four points, you can say the evidences we will discuss over. In this first part, we will discuss the first two evidences. Second part, we will discuss the second two evidences. Okay, so let's start. So in this video, we are going to look, you can say, that the four cases of the evidence and to support and describe this idea. First thing what we can do, that is you can say in my background, first evidences. Perhaps you can see it is here mentioned, there are active fractures in the lithosphere along the ocean floor in a pattern that mimics the shape of the continental coastline. Okay, so these points we have to disclose all this matter, how we can prove. So evidence we will give divide. You can see that we are going to look at is the ocean floor. Now it is, you can say, the days of the Wegener, we are limited to the amount of the data and information we had about the seafloor. For hundreds of years, perhaps you know that we had been able to collect some of the crude information by doing the methods such as, perhaps you know, that is the line sounding methods. Okay, so line sounding method, what is this method? Where actually in this method we would drop a rope with weight on the end down to measure and how deep in different part of the ocean you can say, where, so that if to measure and to measure and enough, and we already surveyed the enough area, and we can create the simple and the basic map of the ocean floor. Okay, unfortunately, you can say these maps were, as I mentioned, were very crude and very limited and very unreliable in this sense. Okay, so this is the main drawback. So this method was followed. But when were you can say the World War First, so and began and ended, and that was began in the 1914 and ended in 1919. So that time, when the eventually World War II again came, and that time United States launched one of the department. The name of the department, perhaps you can see in my background, the Department of Navy Office. For what purpose? For naval research purpose. Okay, and for the first time, the science was driving an effort to map, you can say that, to map the ocean floor. In fact, some of the scientists, perhaps you can see in my background, these two scientists, that the Mary Thorpe and the Bruce Hazen, and developed the first bathymetric method of Atlantic Ocean. Okay, so seafloor they started in the Atlantic in the early 1950s, and they used the technology that is known as the, perhaps you know, that is the sonar methods. Okay, sonar method, and that gave the accurate depth of the sea over the large area, and they had created, you can see, a map that was very much important and very accurate of that time. And if we were to look at the world today and actually to the you can say the blue oceans and drains them from the, you can say, the surface, what we see is that the sea floor is not a vast expanse, a flat desert area as we believed, you can see, the beforehand, but rather than it is the jagged one of the active, okay, active area. Okay, then the mountain peaks, cracks, okay, trenches also found there, earthquake and the active volcano were found there. So in behind me you can see, in the top of the, you can say, the figure there, I wanted to show actually that is the sonar method. Okay, and there are number of volcanoes we can found there in the out of the water, means inside of the water. So this thing we have to, if we see in the different areas, particularly the center of the North Atlantic Ocean, this is seen in my background also. So Atlantic Ocean and extending down through the Southern Atlantic Ocean, we see the massive scarps, and these thousands of miles long mountain ranges that runs down to the Atlantic Ocean basin and essentially mimics of the shape of the continents. Okay, so this thing we have to understand. This set of some of the alarm bells for the scientists, as they believe that this could potentially, you can say, that be the related to the Wagner earlier theory of moving of Earth. So by this we can get the easily information about this. Okay, after that you can say two scientists again, they started actually again the more and more information related to the sea floor spreading. After the work of the Thorpe and the Hazen came to, along with another notable scientists including the Robert Diest and the Harry Hess, who published the work that the further describe the fascinating geological structure that are found in the bottom of the ocean, mainly in the, you can see, the bottom of the Pacific Ocean, bottom of the Atlantic Ocean and Indian Ocean. In fact, if you were to draw a profile, you can say that if you want to draw a profile of America, you can say North America to Europe, you would see something that is very vast expanses in the flat areas, and that is a jagged irregular central and mountain ranges you can find that runs down to the center of the Atlantic Ocean. And so that simply observation on the seafloor, we can find the first evidences we already discussed, that is there are active fractures and, you can say, the volcanoes found over the ocean floor. Okay, so here I wanted to show some figure. In this figure there you can say I already compared two things. First thing, the convectional current with the boiling water. Okay, perhaps you can know that is the convectional current which is generated in the astrosphere. Okay, and the same process follow whatever we can see during time of the, you can see, the boiling of the water in a container. Okay, so this thing we have to understand a lot. Okay, so these are the ridges where the, you can see, the number of ridges, mid-oceanic ridges, from there we can find it. Okay, so this thing, so here you can say another diagram. By this diagram I wanted to show you that, you can say, I want to show you that there is a, you can see the number of cracks that has been developed in the mid-oceanic ridge or the Atlantic Ocean, that is started from the north, you can see the Europe, and that is, you can see the end to the south of the South America. So this area is a vast long coastline area, and active fracture in the lithosphere also found in the ocean floor. Okay, so this is all about this, the first logic, or the first you can see the concept about this. Okay, second concept, or second, you can see the evidence whatever we got in the form of the age of the seafloor rock increases as we get further away the mid-oceanic ridge. So mid-oceanic ridge we previously discussed, this is the mid-oceanic ridge, and here you can see the ages of the rock, you can say that you can see the increases. Why it is increases? So let's discuss. Okay, first thing, based on this observation in previous scientists, you can see the Robert Days, Harry Hess, okay, Thorpe and the Hess, so they discussed a lot. Based on this, Harry Hess developed an idea that along the ridge of the magma from the underground magma chambers was spewing up through the cracks and in the earth's surface, and pushing the plates from the one to another. Perhaps you can see over there, and pushing the slabs somehow, you know, these slabs, you can say the rocks in the either side away from the one another. So in plate tectonic theory we already discussed there are three types of plates movement. Okay, one is convergent, one is divergent, and another is transform. In what would be become the known as a spreading center and divergent plate boundary, as you can see in my background, that is the divergent plate boundary in the mid-oceanic ridge, slowing over the time place. You can see the spread apart, carrying a rocks and the sediments with them, and along with them this boundary as well. Okay, and we see a lots of cracks called the faults and the scraps in the surface of the earth. Okay, surface of the earth. Okay, and here another diagram, you can say that in behind me perhaps, that illustrate with that thing happened along with the spreading centers, that the magma pushes it off and through the cracks and spread the plates apart from above. And so one of the idea was to look for how old the rocks are on the sea floor, as that could be potentially support of this notation, of this notion, or of this concept. If we are to map this the age of the sea floor, if we want to find out the sea floor age, so that time we can see the sea floor age from the, you can see the mid-oceanic ridge increasing if you go further from the mid-oceanic ridge, similar to what we see here. That could be, you can find it is the show as a red. Okay, you can see the red, we have see a young bed surface of the red, and then to, if you go away from the either side of the direction of the mid-oceanic ridge, that is the orange to yellow, yellow to green, and the blue of the age of the. So by this color I wanted to show that is the color or the age of the sea floor gets older to older. Okay, perhaps you can see in my background one of the diagram. By this diagram I wanted to show, here you can see the red, then the yellow to the green. Okay, green to the blue. Okay, so this shows the, you can see the age of our rocks bed, or the rocks on the ocean surface. Okay, on this basis of this, that the, you can say this blue edges, you can see the sea floor gets the older. So only that's the really possible if the sea floor is spreading, because the red one is the younger one, this yellow the more older, then the green is the more older. In this way, that's the age of the rocks structure or the rock whatever found in the mid-oceanic, Pacific Ocean, Indian Ocean, so that is the that is increasing towards the coastal area. Why it is, by this what we can prove, that is we can prove easily that in that the edges or the, you can say, the there is a sea floor spreading, okay, and see that prove the plate tectonic theory as well. Okay, so this is the first part of the seafloor spreading theory. In the next part we will discuss the another two evidence. Thank you for watching this video.